everybody, this is Bill from GMAT and GRE Math Made Simple. This week we're going to talk about how to solve, or not solve, but we're going to actually solve some permutations in practice. A couple weeks ago I started with both the permutation and combinations and what they are and how to solve them. That was in theory. So today we're going to talk about in practice. So the first thing we're going to do is we're going to remind ourselves of the formulas that we have in the types of permutations. So for permutations, we have two types. We have that allow repetition and those that do not. So for our formulas, we have for repetition, for permutations, I'll put that there, with repetition, the formula will equal P, which equals the number we get with that. So P equals n to the R. Now, that's pretty simple. Usually it means like if you have 4 people and you want them all to be able to go through and be able to pick the same person over and over and over for all 4 positions, that's what this means. Without repetition, the formula will be P equals let's see, will be n factorial. So in this case, imagine you had to go through and pick 10 numbers in a lottery. You can't pick the same number 10 times. So what you can do is you pick 10 numbers. Once one gets picked out, then there's 9, 8, and all the way down. So of course, we can't do that. So we gotta make sure we keep these in mind to figure out what type of permutation are we working with. Is it with or without repetition? So here we go. I have the questions already in the blog post already. So if you look underneath this video, you'll see the questions that I'm actually answering on here. I will talk about them out loud and I will go through and actually read them. But if you want to follow, you'll be right underneath. So number 1A, or just go number 1. If the NCAA has applications from 6 universities for hosting its intercollegiate tennis championships in 2004 and 2005, how many ways can they select the host for these championships? And part 1 says A, if they are not both to be held in the same university. Okay, so that means we know it's permutation because, of course, there's so many spots, there's only a specific way you want it to go, and we're only going for 2 years. So when we look at it, we're like, oh, okay, cool. So we look at it, we have 6 universities. So if we go into our thing, P equals the number, which is 6, and this is not repetition because they're not held at the same exact location. There are different universities. You'll see that it'll be 6 this, but there's only 2 years, so we're only going to 2 spots. So it'll be, instead of 6 times 5 times 4 times 3 times 2 times 1, which this equals, there's only 2 spots we're going to go. So we cancel this out right here, and we get 6 times 5, which equals 30. So there's 30 different ways that these championships can be hosted between these locations. Now, that was part A. Part B asks if they both can be held at the same university. So, which means that there is repetition. So this one's a little bit more simpler. As we use the formula here, you'll see that P will equal the number which is 6, and R will be 2 because we're only doing 2004 and 2005. So 6 squared, which equals 6 times 6, which equals 36. You can see the difference between repetition and not repetition. So 2. If there are 5 finalists on the Mr. Rock Hill pageant, in how many ways may the judges choose a winner and a first runner-up? Okay, we can see that this is a permutation again because there's 2 specific positions that we're filling up. Now, we look at our formula again. We're not doing repetition, so we're going to go right with this one again, right there. Okay, so we have 5, let's see, 1, 2, 3, 4, 5, so P equals 5, okay? That's what we have there, and we're not doing repetition, so we'll do 5 with factorial, but we're only going to 2 positions because there's only 2 left. There's only the winner and the first runner up. So this could equal 5 times 4 times 3 times 2 times 1, but there's only 2 positions, which means that this, and this goes away, which equals 20. So there are 20 different ways that the judges can choose a winner and a first runner-up. Okay? Now let's go on to number 3 and 3A and 3B. In a primary election, there are 4 candidates for mayor, 5 candidates for city treasurer, and 2 candidates for county attorney. And how many ways can the voters mark their ballots? Okay? So in this case, we have 4 candidates. So in this case, it's a little more tricky because there's more than just one. So we have 4. We'll just put a thing here. 4 for mayor. I'll put M for mayor. I will put CT for I think city treasurer, and I'll put the 5 because that's the position. And then we also have, I think we have one more, which would be yep, county attorney. So CA. Let's put those there for that. Okay. So we have the positions, the 3 positions, and we have how many we can do for each one. Now it asks if they vote in all 3 of the races. So if they vote in all 3 of the races, it means that there's very specific people that can go to their spots, not repetition. So in this case, we already have the numbers. We can't use the old-fashioned one because it's not just one thing, it's 3 different positions and there's only so many. So in this case, what you would do is you would multiply each by this right here, 4 times 5 times 2, and you get 40. The reason why we don't do it the other way is because there's not just one thing we're looking for, or there's just not one competition or something like that. This is actually 3 separate. These are 3 separate things. So now that's part A. That was the more simple one, I guess you would call it that. The 3B, it says if they exercise their right not to vote in any of the races. This is where it comes tricky, because usually people are like, well, if none of them want to do it, would it be 0 times 0 times 0, right? Because they all don't want it. That's wrong. Because there's still people that are outside. At least need one more person outside of each one of those people in order to be part of that position. So in this case, you still have this right here. You have the 4 plus 1. Then you go through and you multiply that by the 5 plus 1, you multiply that by 1 plus 2, okay? And that'll give you an answer. So let's go through and solve this right here. We have 4 plus 1 is 5, and we have 5 plus 1 is 6, and then 1 plus 2 equals 3. So when you do that, you have 5 times 6, which is 30, times 3 is 90. So if they were to choose not to vote in any of all the races, that means that whoever comes in here has a chance as well. So that means that there's 5 people that are potential for the mayor, 6 for the county treasurer, and 3 for the attorney, which gives us 90 total possibilities that if they chose not to go and vote into any of those of these right here, these 3 positions, there's 90 different ways that they can go through and be elected. So this is what we have for this week. Next week we're going to go through and do solving combinations in practice. I'll post the questions up just like I did this time with the blog post. It'll be underneath the video. I hope you guys enjoy this. Please hit up the website gmatgreMathMadeSimple.com, or if you'd like to go to a meetup, we have GMAT-GRE NYC meetup group where we do questions just like this in practice, and we do at least twice a month. So I hope you have a great day, stay safe, and I'll talk to you later.